All right, welcome to section 5.4. We're moving on here, talking about hypothesis testing for two proportions. We've been doing some with one proportion, and really what happens here is we're just comparing a couple of independent proportions, and we have some parameters here. The samples need to be independent. We'll be given information like that. We're not trying to trick you with these questions. And then this one you'll want to check. The number of successes should be at least 5, and the number of failures is at least 5 for each of the samples. So in this case, what we're doing is trying to see if two proportions that we find are different or the same. And we still have the same steps as we had with our previous hypothesis tests. The null hypothesis is that the proportions are going to be equal to each other, and then the alternate can be that they're different. One is less than or one's greater than. And so we have our formulas here that we're going to be using. We're introducing now a pooled probability. That's what this P sub C is. And what we do is we total up the successes for the two proportions and total up the sample sizes of the two proportions. And that is our pooled proportion. And then we'll use that to find our new standard error. That formula sheet that we haven't been using, we're starting to use it now. So we have our pooled proportion successes, and then this is really our pooled proportions failures. So P sub C times 1 minus P sub C, and then we multiply that by 1 over our first sample size plus 1 over our second sample size, and we're doing the square root of that whole thing. That becomes our standard error. And then just like previously, when we're dealing with proportions, we're getting test statistics that are normal, so we're going to use normal distributions to find out those p-values from these test statistics. And you'll notice here we have p hat sub A, so that's the sample proportion for A minus p hat sub B, and that's the sample proportion for B, and we divide by the standard error. And we tend to just use these proportions in the same order that they show up in our questions. So if I go here, first question, and I've got Excel because I'm planning to use Excel to do these. And so as we read through this, you are testing the claim that the proportion of men who own cats is smaller than the proportion of women who own cats. You sample 200 men, so this is N sub A. And if you wanted to add a context here like N sub M, that would probably be fine here, however you want to track it. But this is the number of successes of our the sample size of our sample of men. And then we have 40% of them own cats. So that's actually P sub A, and it's 0.4. Now we need to have the number of successes, so X sub A. And if you want to, write those in a better way, that's fine. We'll just take the number of the sample and multiply by the probability of success here. Don't know why it's not letting me choose it, but there it is. And this gets us X sub A. Similarly, with the women, N sub B and P sub B and X sub B. I know I'm going to get all those things, so I have 160 women in the sample and 0.75. Now we had some qualifications that we needed at least 5. We've got that here. Just choosing the order differently there, see if it works out. So again, these are, if we take the probability of success and multiply by the sample size, we get the number of successes. So in these questions, sometimes you'll have to find the number of successes, sometimes you'll have to find the probability of success, sometimes you'll have to find the total. But you need to know all of these things to figure out your pooled proportion. So that's P sub C. And again, P sub C is the number of successes. So we add up the successes and divide by the total sample size. So N sub A and N sub B. And this is our pooled proportion. So if we put those together, that's the probability of success. Now we need to figure out our standard error. And the standard error is the square root of this pooled probability times 1 minus itself times 1 over X sub N, N sub A plus 1 over N sub B. And just letting Excel do all this work here, oops, I forgot a set of parentheses. It'll add it for me after barking a little bit. So just letting Excel do all the work for us. So we have the probabilities, we have the standard error, and then now we need to find the test statistic. And it is, if I take P sub A minus P sub B, and then divide by the standard error, I'll get our test statistic. And I think it says to round these to 2 decimal places here for this question. So we'll do that. And there we go. So in this case, we didn't have to run through the whole thing. We were just trying to find the test statistic. I think I'm going to save this one for the next video because I'm not quite sure I have enough time and I don't want to feel rushed on this. So this will be it for the first example. Again, going through here, we have to figure out, in this case, we had the proportion of success. So these guys, P hat sub A and P hat sub B, we had to use that information and the sample sizes to find the X's, get our pooled proportion, use our pooled proportion, and our sample sizes to find the standard error, and then working kind of like our z-score, our test statistic. Pretty common here. So on the next video, I'll kind of run through an example with all the parts, but this has us at least getting our test statistic, figuring out our pooled probability, and our standard error.